Welcome to Study Loop.
19.73, so we're discussing speed control for the ventilation fan in cars. And one way to do it is to put a resistor in series with the motor, which reduces the current going through the motor. And this is, in fact, how many cars do this. And it has like a set of switchable resistors you can use, and it's not terribly uncommon to end up having to replace this resistor network because the resistors end up dissipating quite a lot of power for as far as normal resistors are concerned. Obviously, they use ones that are rated correctly, but still they fail sometimes. So we're told that with no resistor in series with it, the motor draws a current of 5 amps when it's connected to the 12-volt battery. So for part A, we want to figure out what resistor we need to get 2 amps instead, and then for part B, we want to figure out the power rating that this resistor has to have. So from Ohm's law, we can figure out that the motor voltage, or the motor resistance rather, is our 12 volts divided by 5 amps. This gives us a resistance for the motor of 2.4 ohms. So we have V equals IR again. Now this is our 2 amps. This is our equivalent resistance. So I times the resistance of the motor plus our series resistor. So our series resistor is going to be V over our desired 2 amps minus the resistance of the motor, which we're told to assume just doesn't change with the applied current. And so then this works out to be a 3.6 ohm resistor that you have to put in series with the fan to get this decrease in current. Now for part B, the power a resistor dissipates has a couple forms. The useful one here is I squared R. V squared over R is the other one, but since we're already given the current, we don't really want to go back and find what the voltage across this resistor is. We could do it that way, but there's not much point. And so this resistor dissipates 14 watts, so its power rating has to be at least 14 watts, and preferably should be a bit more as a safety factor. Just sort of a general good engineering practice that, in the best case scenario, it needs, XYZ power rating, and it should be a bit higher than that because you might not always have the best case scenario. So there we go.